Hello guys, welcome to Friends in Tech Automation. We provide practical PLC and SCADA and IIoT training. Welcome to our YouTube tutorial, PLC programming. And our topic today is about subroutines. It's about subroutines. So our previous video, kindly check our previous video. We talked about jump and label, or basically jump and call. So these are techniques used to control program flow. It's a technique used to control program flow. What is program flow? We say that program flow, it's a way of interrupting PLC normal way of executing program, because PLC execute one network after the other. So one network at a time, I mean. So from network 1, network 2, network 3. But the moment you introduce jump functions, or what are called conditional jumps, PLC can jump from network 1 to network number 3, ignoring network number 2. That is what is called program flow. So jump functions are just used to control one ladder network. But what about if you want to control a section or a block? Is what now you need to learn about subroutine. So what's a subroutine? So subroutine is actually a sequence of program instruction that performs a specific task, packaged as a unit. That is very important. It's just a sequence of program instruction that performs a specific task, packaged as a unit. For example, if you want to perform multiplication of two numbers, let's say A and B, so you can write a function and call it multiplication function. So this function, it performs only one task, and that task is multiplication. And the good thing with the subroutines or functions, that can be used in, they can be called multiple times. They can be called multiple times. So this unit can be used in multiple places within a program. So a subroutine are used to organize programs and to implement repetitive operations. This is very important. I think we can underline this here. This here. Repetitive operations. An example is that I have analog signals coming from PLC input, and in order to use these analog signals, I need to do scaling of these analog signals. So what I will do, I can build a program to handle scaling of analog inputs. All right, scaling of analog inputs. That is a subroutine. So anytime I need to perform scaling of analog inputs, I will just invoke or call that subroutine. So in high-level programming languages like Python, C#, Java, they are called functions or methods if you're dealing with object-oriented programming. But now in PLC, we call them subroutines. But in TIA Portal, you find them, they are also called function, okay? Functions. Now let's demonstrate something here a little bit, how we can use subroutines in TIA Portal. How you can use subroutines in TIA Portal. Now, TIA Portal, if you look at TIA Portal here, this is our TIA Portal. So if you come to program blocks, let me just zoom this out. Magnifier. So this video I will do it in two parts. So the first part will cover what is called function. The second part will cover what is called function block. So if we zoom this here, if you come to programs, PLC program block here, already you have an existing block called main OB1. Main OB1. So let me explain what is main OB1 and other different types of blocks in TIA Portal. So what we have here, let me go to my notes here. So if you go to TIA Portal program blocks, we have program blocks. So if you come to program blocks here, we have different types of blocks in TIA Portal. So the first one is what's called organization block. Organization block. In other words, OB. So this is where you write your main program. So in organization block, this is where you write your main program. So main program is written here. Main program is written here. This organization block is very important because it is part of PLC scan cycle. Because we say that PLC operation is simple. PLC scan inputs. It scans inputs. Then it executes the program. It executes the program, then it updates. It updates output. Then it goes back to scanning inputs. So it scan inputs, execute program, and update outputs. I know there's a step of self diagnostics and communications. Now, the program that is being executed here, this program here, it is OB program. It's called OB program, all right? It's OB program. So that's very clear. So other than having organization block, we have another block called function. It's called function. In other words, in TIA Portal, you'll find it FC. Then we have another block, function block. Function block. In other words, FB. The difference between these two is with function block, we have what is called DB. In function, there's no DB. Why? So by this, I mean that with function block, after doing calculations, it will store the states in a DB. DB is just a storage, okay? It will store the states in that DB. But function is like a calculator. For example, if you perform a simple arithmetic, 10 plus 5, that is 15. So after that, you cannot retrieve your answer again. Let's say 2 days has passed and you want to see what was the answer. You'll not find it because calculator does not store the final answers. So that is what is function. But function block, it stores the final answer in what is called DB, data block. Then we have finally we have what is called data block. Data block. So this is what is called instance data block. And this here we can create what is called global data block, global DB. So we'll start with function because we can create a subroutine using function or using function block. So I will start with function control. So if you go to TIA Portal here, go to program blocks. So come to program blocks here. So you have program blocks. Then double click add new block. So these are the blocks that we have here. So you can add organization block, this here. You can add function block, FB. So you can see description here. Data blocks save. If you select function block here, function blocks are code blocks that store their values permanently in instance data blocks. So they remain available after the block has been executed. Then you have function. So functions are code blocks or subroutines without dedicated memory. Then you have DB. So DB is where you can save user program. It's just like a database or something, right? That is DB. So we want to start with function this here. Let's start with function. And I want to write a function, just a simple function to run a motor. Simple function to start a motor. So we can call it or let's just do a simple function for analog scaling. Let's call it analog scaling, that's it. Then you have to select FC, then you have to click OK. So right now you can see that other than main OB1, I have analog scaling block. That is FC1. Now let me just remove this guy. So this is FC. If you open analog scaling, this is FC here. All right, this is FC. It's really simple here. What we'll do, I'll just create a program. You don't really need to understand this here. A program for scaling, okay? So I'll just drag this here, an empty memory box. This is empty memory box. Then I just call it scale. I know we'll have a topic of scaling. Let's just call it scale. Then this input, this is coming from sensor. Then these are limits. So you want to scale your input to a given limit. So let's say that we have temperature sensor. All right, let's say we have temperature sensor, and what you want to display to operator is a range between 0 to 100 degrees Celsius. Let's say that. What you want to display to operator is 0 to 100 degrees Celsius. That means that lower limit is 0.0. Highest limit here will be maybe 100 degrees Celsius. So 100.0. That's it. Then the output here, let's call it scaled input. So let's just call it scaled input. That's it. And let's define this as a memory. So define tag, and we'll just define it as a global memory. That's it. And this here, let's just call it rate value. Let's go val. And I'll just define it as a temporary variable. Sorry, delete this. So define this as a temporary variable. That's it. Then this one set as m 0.1. Just a tag. No, that is used. Let's say m 0.4 something. Okay, that's perfect. Now lower limit is 0.0, highest limit is 100.0. So what's happening here is that I don't have an analog sensor right now, but I need to test my program. All right, I need to test my program. So what I'll do, I will add what is called db. So go to add new block here. Then this time we want to add data block, db data block. Let's just say okay. So inside this data block, I want to define some dummy data. Let's call it analog. Sensor data. And type here will be, let's say, integer or something. Then I want to start, let's just guess any sensor value. Let's say 1000. That is sensor value right now, 1000. So if you come to analog scaling here, I want this input to be from a sensor, but I don't have a sensor. So I will use data block here, sensor data. So come here, double click this, then click on this here, then go to data block 1, then select sensor data. So this will act like it is coming from the sensor, right? It will act like it's coming from the sensor. So that's scaling. and we are done. So this is just a function. So we have just created a subroutine called analog scaling FC1. We just created an analog scaling function or a subroutine. But the problem is that if you run this program, let's start simulation here. Let's just start simulation here. Consistent download, then load the program. That's it. Then we can monitor input output. So we expect that this will scale this 1000 to a value between 0 to 100. So you have to take your CPU to run mode. You have to take your CPU to run mode. That's it. So if you go to main block here, we need to go to monitor input output as well. So you see this here, it's working. Everything is working, it's active. So if you come to analog scaling, nothing. It's not working completely. Why? Because PLC has ignored this program. This program is not part of OB. It is not part of main program. So you need to call this function or this subroutine to main program. I want you to see this different clearly here. Right now, this program or this block is not activated. In simple words, PLC is not seeing this program. Why? Because we said you scan inputs, you execute the program, you update the output. But the program that's been executed must be from OB. It must be your main program. So if this subroutine is not part of that main program, it will not be executed. That's why it cannot scale this 1000 into a value between 0 to 100. So what will happen here, I will go to main program here, double click this, then I will call it here. So in simple terms, let me just label this network number 1 as calling analog scaling function or subroutine. That's it. So how do you call a function? It is simple. You have two ways of doing this. So you can just click on this empty box, then double click on this question marks, then you can write the name of your function. The name of your function is analog scaling. So just type analog scaling, then enter. So that's it. So by doing this, you have called your subroutine. Okay, you have called your subroutine. That's it. You have called your subroutine. Also, what you can do, instead of doing this here, you can delete it, then just drag this analog scaling, this subroutine, to your network, just like that, and that's it. So what will happen if you run this program again? So we'll download the program, and let's go to analog scaling block, load, come here. Now we'll just take our CPU to run mode, then monitor input output. Now you see what's happening now. Now it's activated. So that is what is called subroutine. That's how you can create and call a subroutine in TIA Portal. And here we have used function FC. So we have used FC. So I want to explain the difference between FC and FB. Those are two different subroutine blocks, FC and FB. So this is FB. So in our next video, I'll try to explain about FB. What's the difference between an FC and an FB? But before I can do that, let me do something here, because we are saying that if you develop a subroutine, you can call it multiple times. You can call it in multiple times in network 1, network 2, network 3. For example, I'll go offline here, or what I will do, I just delete this input. I delete this input, then just follow my cursor. At block interface here, we have a table. We have a table. I like to describe them as placeholders. Okay, let's just expand this here. So this here, you can define placeholders for your input. So let's say, for example, at in, I want sensor input. Sensor input. That's it. And this sensor input, I want it to be an integer. So data type will be integer, okay? So data type will be integer. That's it. Perfect. So that's the only input I want. Then at the output, I want scaled input. So this will be placeholder for output, scaled input, okay? Scaled input. And this here is this is real, if I'm not wrong. So this here is real. That's it. So these are what are called placeholders. So by doing this, instead of defining your tags here, you just have to place placeholders. Scale input. That's it. So that's a placeholder. That's a temporary variable or a temporary tag. That's why it is starting with hash. Then here you can have analog or sensor input. Sorry, sensor input. That's it. Then just save your program here. So again, you need to call this. So if you go to your main program here, you see there's some error here. Why? Because you need to update this block. So just right click, then update this block, okay? Update block call. Okay, perfect. So it's now kind of different with what we had previously. So here you have to input data from sensor, and here you'll get your scaled input. So I have those tags defined as memories. One is defined as a DB. So I just go to DB here, data block 1, then I select sensor data. That's it. Then I can go to scaled input. Then I will select scaled input. That's it. Then again, you can run this program. It will do the same thing. Stop your CPU, run this, select consistent download, load the program. That's it. You see, that is what's happening here. So you can change this because this is a value from a sensor. If you have a real sensor and a real PLC, then you don't have to do a data block here. Because it's a sensor, it's an analog sensor, it will be giving you different values in real time. And that values will be scaled also in real time. So what we can come to our data block here and we can modify. So this is what we are monitoring. So we can modify this to maybe 2000. So this will be a problem to 1000. Okay. I'll just stop CPU here and load this again. Okay, so we have changed that to 2000. Let's see what will happen here. Take it to run mode. Then monitor input output. That's it. So you see it is now 7% or 7 degrees Celsius. I don't know, it depends what is your input here. Is it a temperature sensor, or is it an RTD, thermocouple, flow meter, level meter? So if you're not sure, just scale it between 0 to 100%. Alright, thank you for watching this video. If you like this video, subscribe to our channel and share our content.